Welcome back. In this video, I'm going to introduce to you the three trig ratios that you're going to need to find unknown sides of a right angle triangle. The three trig ratios: sine, cos and tan. What are they? Well, they're just names we assign to the ratio of sides in right angle triangles. It's pretty straightforward. Sine is equal to the opposite side over the hypotenuse, cos is equal to the adjacent side over the hypotenuse, and tan is the opposite side over the adjacent. It sounds a little bit confusing, but if we bring them all together, we create a word that we can say SOHCAHTOA. SOHCAHTOA. That stands for sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. And if we write it in this funky little way, it's so easy to remember. But why are we using this? Well, you might remember last lesson we actually labelled the sides of our right angle triangle. We now need to apply either sine, cos or tan so that we can find an unknown side. Okay, there are two types of unknown sides. We can have an unknown on the top, which is in the numerator. Remember, fractions have numerators and denominators. So if we have an unknown in top, it's slightly different to if we have the unknown in the denominator, which is the bottom of the fraction. Let's start with example 1 though and find an unknown in the numerator.
3, 2, 1.
Okay, let's start with this right angle triangle. Why don't we give it a hypotenuse of 8 and a side length of x. Let's make the top angle 38 degrees. Now remember, the most important thing is we need to label our sides in reference to the angle 38 degrees. So let's label the opposite, the hypotenuse and the adjacent. But you'll notice we don't have an opposite side, we only have an adjacent and a hypotenuse. So let's go back to our little SOHCAHTOA and think, which one of these has an A and an H in it? That's right, it's the car for cos. So we write an equation in cos, and the equation is cos of 38 is equal to x over 8, the adjacent over the hypotenuse. This is now just a simple equation that we need to solve for x. So we'll multiply both sides by 8, and all we do is pick up a calculator. And look how simple it is. 8 cos 38. Punch it in. Woohoo! Answer, x equals 6.3. That's it. But hang on, what if my unknown was in the denominator like we said before? Well, let's just try another example and see what happens. This right angle triangle, I'm going to give the hypotenuse x this time. We'll give a side length of 5 and let's put the base angle at 31. Okay, step 1, every time we apply this, label our sides, opposite, hypotenuse and adjacent. This time we don't need the adjacent side, we just want the opposite and hypotenuse. So looking at my SOHCAHTOA, I realise, sine, that's it, the SOH of the SOHCAHTOA. So let's write the equation. Well, the equation says sine of the angle, sine 31, is equal to the opposite over the hypotenuse, which is equal to 5 over x. You can see that my unknown, my x, is in the bottom of my fraction. So this time we need to solve for x. What we really do is we multiply both sides by x, then divide both sides by sine 31. But hang on, let me show you a little trick. When you have x in the bottom, in the denominator, all you have to do is swap them. Swap the x, swap the sine 31, and you calculate x equals 5 over sine 31. Again, put it in your calculator and you'll get an answer of 9.7. That's it. All you need to do to solve unknowns in right angle triangles is step 1, label your triangle. Step 2, pick SOH, cut or TOA, put it into the equation and then solve it. You either solve it from the numerator or the denominator. That's it. Now, if you'd like a few more examples, subscribe. We've got a whole page waiting for you. Otherwise, if you enjoyed this video and you'd like more content, give us a thumbs up, like us, and we'll see what we can do.